Let's take another example, this time one with only a single variable, but with multiple connectives, in order to explore the concept of scope, which we can define as the domain of logical control exercised by a statement connective. Often, the scope of a connective is demarcated by parentheses, brackets, or braces. Here's our example, which reads both if C, if and only if C, then C, and it is not the case that if C, then C. Sounds complicated, but by using parentheses and brackets, we can easily parse this expression, whose complete truth table requires only 2 lines because there are only 2 possibilities. C can be true or it can be false. We can skip the reference column and simply input the 2 possible values for the atomic sentence C like this. Here, the order of operations matters. So we would need to start with the connective with the least scope and proceed to connectives with successively larger scopes and end with the main connective. The main connective is the ampersand, whose 2 conjuncts include the substatements within parentheses and, in the case of the conjunct on the left, also brackets. The conjunct on the left is read as follows: if C, if and only if C, then C. The conjunct on the right is read, it is not the case that if C, then C. Let's start with the conjunct on the left. Inside the parentheses, we have a biconditional sentence, namely C, if and only if C. Remember the rule for biconditionals. They are true when the values match on either side of the triple bar and false otherwise. Do they match? Yes. So we'll input the correct values for the biconditional like this. Let's now move to the connective with the next greatest scope, the conditional within the conjunct on the left. The rule for conditional states that a conditional is false just in case the antecedent is true and the consequent is false. Otherwise, a conditional is true. Well, what does the truth table indicate? In the first row, both the antecedent and the consequent are true, so the conditional as a whole is true, which we'll input like this. In the second row, the value in the column for the biconditional, which represents the antecedent, is true. The value for the consequent, found beneath the horseshoe in the second row, is false. So the antecedent is true and the consequent is false, which is the only case where a conditional is false. Let's enter that value in the second row of the column for the conditional like this. We've completed the values for the conjunct to the left of the ampersand. Now, let's move to the conjunct on the right, which is read as, it is not the case that, if C, then C. This conjunct is composed of a negation of a conditional. The horseshoe has a smaller scope than the tilde, as the parentheses indicate, so we'll input the values for it first. In the top row, where both the antecedent and the consequent are true, the conditional as a whole is true, so we'll enter a T. In the second row, where both the antecedent and the consequent are false, the conditional as a whole is true, so we'll enter a T like this. Now we're set to move outside the parentheses to the tilde, symbol for the connective for negation. We need to negate the values found in the rows underneath the horseshoe and place them beneath the tilde, like this. Now we're set to move to the main connective, which is the ampersand. Looking at the values for the 2 conjuncts, that is, the values beneath the horseshoe on the left and the tilde on the right, and applying the rule for conjunction that both conjuncts must be true for the conjunction as a whole to be true, we get the following values, which we place underneath the ampersand. The complete truth table for this sentence looks like this, with the column for the main connective circled. In each row of the truth table, the values beneath the main connective are false, which means that our expression can never be true. The conjuncts are contradictories, and the expression as a whole is a contradiction. So, we've seen a truth table for both a tautology and a contradiction. Next up, we'll take a look at the truth table for a sentence that is sometimes true and sometimes false. It's what logicians call a contingency. Stay tuned.